Problem number 19. Find a formula for the parabola with a vertex -5, 6 and that passes through that point. Okay, so remember that the general formula of a quadratic function in a vertex form is f of x equal a times x minus h squared plus k, where h comma k is the vertex. Okay, so then plug in the information about the vertex. The parabola equation should be looks like this: ax minus h, so x plus 5 squared plus k, and the k is 6. Okay, so now our job is to find what is the a, and we can use this information. So this information tells us that f of -4 is equal to 9. So just use this. So let us use this. So 9 is equal to f of -4, but according to this, f of x is that. So a times -9, we plug in -4 here. So f of -4, plug in x equal -4. -4 plus 5 is 1. 1 squared is 1. So a times 1 squared. So I don't need this, just a, because 1 squared is 1. A plus 6. So a plus 6 is 9. Therefore, a is equal to 9. So that the conclusion is f of x is equal to, so a plus 6 is 9, a is equal to 3. So f of x is 3x plus 5 squared plus 6. And we are done. Next problem. A ball is thrown straight upward at an initial speed of 240 feet per second. From physics, we know that the ball will reach a height of h feet after t seconds, where h and t are related by the following formula. In order to determine when the ball hits the ground, you need to... So, ball hits the ground is exactly when the height of the ball is 0. So basically, in order to find when the ball hits the ground, is the same thing as to find the t when this expression is equal to 0. And that's exactly to find the t-intercept. Find the positive t-intercept. Yeah, because we want the so the first t is correspond to the initial condition when the ball is still in the ground, and the t positive is exactly the time when the ball hit the ground. So the answer is D. Problem number 21. Let f of x and find the domain of f of x. So remember that the square root only accepting a non-negative input. So first we need x minus 2 to be greater or equal to 0. But also, because this square root is in the denominator, we don't want the denominator to be equal to 0. But the denominator is equal to 0 exactly when, so we want these two conditions, this to be non-negative and the square root not equal to 0. And when is exactly square root of x minus 2 equal to 0? So we don't want x to be equal to 2. So we have two conditions. The first is x minus 2 is greater or equal to 0, and the second one is x not equal to 0. So from here we have x greater or equal to 2, but x is not equal to 2. So from these two conditions, x must be positive. I mean, must be bigger than 2, or in the interval notation from 2 to infinity. So the answer is D. Solve the inequality and graph the solution on the real number line. Okay, we have absolute value of x minus 2 less or equal to 4. So remember, we can interpret this expression as the distance from x to 2 is less or equal to 4. Okay, so here we have 2. So first of all, we can ask ourselves, for which x does the distance from x to 2 is exactly equal to 4? There are two x's, which that property, which is x equals 6, 3, 4, 5, 6. And if you move to the left 4 units, 1, 2, 3, 4, negative 1, 0, 1, 0, negative 1, negative 2. Okay, so in order we keep the distance from x to 2 to be less or equal to 4, we should stay between negative 2 and 6, because whenever we go to the right of 6, then the distance from 2 will be greater than 4. So the answer is negative 2 up to 6, which is this one. The other way is by algebraic method, so we need to translate this into an equivalent statement, which is x minus 2 is between negative 4 and 4. Adding 2 to each of these, we have negative 2 less than x less than 6. Oh, I'm sorry, I should put this with equality sign. So we have the same answer, which is E. Okay, that's all for page 5.